Okay, I hope it works now. Okay, can you hear me?
Yes, we can.
Okay, thank you. Let's look at this list component. Okay, so I have this list frame, X and J frame. Again, like previously, I have the names and the colors, two arrays, list frame, I call the super, and I I make a new list, JList, color JList. Okay, JList. And my name is color JList now, color names. And the set visible row count is 5. Good. And set selection mode is, see, there is this single selection mode and multiple selection mode. With the multiple selection mode, you can select more than one item at the same time. But in this case, I'm not going to let that happen. And I have a scroll pane. So I am adding a um, scroller to the list like this. And then I am writing this anonymous inner class. Very simple, right? List selection listener. So this is not item listener. This is not action listener. This is list selection listener. It is special for the lists, and I need to implement this value changed. Okay, and I get this event list selection event, and I get the this is how you change your background. Whose method is this get content pane? Get content pane. Whose method is this? Get content pane. It must be a method of what? It must be a method of JFrame, right? So you get your content pane, and then you set your background that way. Your background color is set using this method get content pane dot set background. Then you choose the color of the color lists get selected index. That's it. I mean, very sparse code, and I can do this that way. I can select any color that I like. And remember, I have to add this scroller. I have to add this scroller uh, explicitly. Otherwise, the scroller will not be there. I cannot scroll down and up. Okay, so nothing much new here other than the new list selection listener. No action listeners, no state change, etc. This is just list selection listener. Okay, let's move on with other types of. By the way, this multiple selection frame. Okay, let me show you that one. Okay, so when you run this program, it's going to select a number of items from this list and hit the copy button, and they will be copied to the right side. So how many components do I have? How many J components do I have in this window? 1, 2, 3, 4, 5, 6. What? It is not 0. It is not 1. How many components do I have in this window?
One list, one button, and one text.
Yeah,
It's
it looks
three.
like that way. It looks like 3. I am not sure what this one is. It might be a text entry field or maybe a list too. This one could be a list. Let's look at the implementation. Implementation says that I have list and yeah, we have two lists, okay? Two lists and one button. This is a color names and this is the copied one. Let's see what kind of differences are there, okay? Yeah, one of them has a scroller. Okay, the one on the left has a scroller, the other one doesn't have it, I guess. New scroll pane J color list. J color list. What is the other one? J copy J list. Where is copy J list? This one. Yeah. Copy new list. Yeah, it is. This one doesn't have a scroller. Yeah, well, they have a scroll pane. Yeah, they have a scroll, but it is fixed cell width and height. Okay, visible count is 5. It looks a little bit different, but it's a list too. So with the multiple selection, you make the multiple selection possible, multiple interval selection, and that's it. The rest of them is kind of same. So I'm going to skip this one. Let's look at some examples about mouse events, what we are going to do with the mouse. I mean, item state changes, selection changes, etc. My mouses are no different, mice are not no different. If something changes with the mouse on my component, then I will get the corresponding event. That's why I have mouse listeners and mouse motion listeners. And I have this mouse input listener, which combines both of them. And let's look at one example. Let me show you this example here. When I run this, an empty window, there is just one text field at the bottom, maybe a label, maybe a text field, I don't know. It might be a label. Okay, it's a label, I guess. So mouse outside the panel. If I move my mouse inside the panel like that, okay, I make the background green and I print this message at the top. Mouse moved at 8,13. So this is position 8,13. And if I click anywhere, I just print this message, mouse clicked at this one. If I press the mouse button, pressing is different from clicking, as you know. I get this one. If I drag it, if I release it, I print all that information on my window. Okay, so let's go to the, okay, my main is almost the same. I just make a new main frame of my mouse tracker frame and set the size and make the visible true, and that's it. Okay, let's look at our simple code of 90 lines. Okay, so this one says that, okay, I have a Jpanel. So Jpanel is a component on which you can draw stuff. Okay, I think last time I talked about it a little bit. Jpanel is something that you can draw on, and JLabel is something we already know. It's just a label to put some text on the screen or some icon on the screen on the window. Okay, so I will have two components. I am going to use this label to print my messages, and this panel will be used to change the background of the window. Okay, so constructor, super constructor, mouse panel, I make a panel, and initially its color is white. And see, I didn't say my layout is flow layout. Okay, I didn't say anything about the layout. So specifically, I am telling the window manager that I am going to put this panel at the center of this window, border layout.center. Okay, and I have a label. Okay, this label will be added to my frame to the south. Okay, there is the center of the window, there is the south, north, east, and west. Okay, so this is a border layout stuff, and this is not flow layout. So this is the first time we are using any layout strategy other than the flow layout. Okay, so let's move on. What are we gonna do? I am going to add this mouse handler. Okay, to my mouse panel. Okay, this is my mouse panel again, mouse panel, and it looks like I am going to add two listeners, but it is the same thing. So At a mouse listener, at a mouse motion listener, I am using the same handler because this mouse handler implements both mouse listener and the mouse motion listener, both of them. Let's look at this mouse listener and mouse motion listener. I think it was documented here. Okay, this is mouse listener. The mouse listener includes these methods: mouse pressed, mouse clicked, mouse released, mouse entered, mouse exited. Okay, 4-5 methods. Also the mouse motion listener, it is mouse dragged and mouse moved. So 7 methods. Okay, 7 methods are included inside the mouse stuff. So we are going to implement them. We will have to implement. It is not as simple as implementing action item, etc. Okay, you need to implement all of them. Otherwise, your class would become an abstract class. That wouldn't be a good thing. So you will have to implement all of them. Let's look at them one by one. We are implementing both of these listeners. So I will have to provide all those 7 methods. Mouse clicked. Okay. Whenever I get the click event, I remember that my status bar is my status bar is my label, and I can change my label's text. That's what I'm doing. I am setting the text of my label with this. Okay, the mouse clicked at integer, and the integers are obtained from this event. This mouse event sends its x and y position automatically. Okay. These are sent automatically. And how about this one, mouse pressed? Okay, so these and x and y positions are automatically sent again. Mouse released, these x and y positions are sent automatically. So this one, 1, 2, 3, 4, 5 will be the members of this mouse station interface. Mouse entered and mouse exited. Okay, 5, 4, and 5. And then the other interface, mouse motion interface, mouse dragged again. It is very similar. Okay, so I get that, and I get x and y positions, and I implement them. That's it. So this is how you handle the mouse events on your components. By the way, I have 2 components added. One component is this part. Okay, this part is, let me use red. Okay, this part is my panel, and I am handling only the mouse events that is happening inside that part of it. Okay, I am not handling any events that is happening around here or there or any other place in my screen. Okay, where is this coming from, this green stuff? Okay, did you guys, who sets that green stuff? Mouse entered. Oh yeah, okay, here it is. Mouse entered. Whenever the mouse enters, I set my background to green. Whenever the mouse exits, I set my background to white. Mouse panel set background. Okay, that green and white stuff comes from there. Okay, any questions about this mouse handling? I mean, it is as expected, just a new event handling mechanism. And if you provide all that stuff, you should be fine. It's a matter of looking at the documentation and what kind of things are possible and what kind of information I am getting. Okay, so well, now we are ready to make a program that I showed you at the beginning of today. I showed you a window, and you are drawing some pictures using your mouse drags, right? So you are ready to do that because you know how to detect the mouse drags, and you know how to do that kind of stuff. But I am not going to talk much about that program because I don't have much time. I mean, if you like, I provided the slides, you can look at them. One problem with the mouse listeners is this: since there are 5 methods or 7 methods to implement, right? Sometimes it is too much typing, right? I only need to know if the mouse entered or not. Okay, if I need to know if I need to know if mouse is entered or not, I don't have to. I mean, I don't like that. I don't like the fact that I have to implement all of the 5 methods. Okay, to prevent this from happening, they develop these adapter classes. Okay, these adapter classes, these are not interfaces. These adapter classes, they implement all the mouse handling methods by providing empty methods. Okay, when they implement that, they say that, okay, I am implementing that, but this is empty, it is not doing anything. So it's a default implementation for all event handling methods. It's called adapter classes. And if you are going to modify, if you are going to provide only one implementation out of all 5, then instead of implementing the mouse handling interfaces, just extend this adapter classes. And these are available for mouse adapters, okay, mouse listener, mouse motion listener, and that will be so these are some of the adapters that are already extended: component adapter, container adapter, etc., focus adapter. Okay, so mouse adapter, mouse motion adapter, we already have those. So let me show you one example out of this. Okay, so just show you this window, simple window. Click the mouse. Okay, if I click the mouse, if I click 2 times, if I click 1 time, if I click 5 times, it just tells me how many times I clicked. This main is the same. I'm not going to look at it. There's 50 lines of code. Okay, JFrame, I have just a single J label. Okay, I have a single J label, and I have mouse details frame. Okay, and I have a new label. I added it to my frame, and I added this mouse motion listener, mouse click handler. Okay, this is my mouse click handler, and let's look at the mouse click handler. See, this mouse click handler doesn't implement any interfaces, but it instead extends the mouse adapter, and the mouse adapter implements all those mouse interfaces with default behavior. By default behavior, I mean it doesn't do anything. So out of all the implemented methods, I am going to override this mouse clicked. Override is the right term because this mouse clicked is in C++ terms is a virtual function. In Java terms, it's a late binding function. Okay, I am overriding this mouse clicked. I get the X and Y positions. Okay, and then so this event will give you the click count too, how many clicks I did. Is meta down, is the right mouse is down or not, or the center button is down or not. Okay, I get all of those. I get, merhaba hocam, sağ olasın, ben içtim ya. And then I set the text to the status bar, and that's it. Okay, so nothing new here. The only thing is that this mouse adapter is available. You don't have to implement all the methods of the mouse listeners. There are many of them. These kind of conveniences are available. That's what we are saying. Okay, so what else? So we talked about that. That's good. Okay, so let's move on with maybe. Okay, so these are some of the methods of the event, mouse events. And yeah, this is the program that I told you about. Well, it is not very well. For some reason, this main is a little bit longer than what we had. So I have a, see, this one is not making a new object from a class extended from JFrame. I make a JFrame here, and I make a new paint panel, which is my panel. Okay, instead of making a new JFrame, it's making a new paint panel, and this paint panel is added to my frame on the fly, and I add this J label and make everything visible and make it true. So it is a little bit different from what I did before. I didn't make a new JFrame class. Instead, I make a new panel class, and this is the panel, Jpanel. We always extended JFrames, now we are extending Jpanel. Okay, so I am making a new component for myself. Okay, this panel has a 2D points of 10,000 array. Okay, new point 10,000. Constructor paint panel. Okay, so add mouse motion listener, which is a new mouse motion adapter. Okay, anonymous inner class. Whenever the mouse is dragged, this is what I do. See what I do? I add a new point to my points array. I increment the point count and repaint. Repaint paints my current window. Okay. Who's going to paint my window? Of course, I am going to paint it, and that's the paint component. I am overriding this paint component of my Jpanel. I call my superclass paint component first with the graphics object, and this is what I do. Fill oval is just painting small circles. Oval, I mean, if you make the width and height of the oval the same, that becomes a circle. So I am painting circles of size 4, of diameter 4 at these XY positions. Okay, so that's how the things are done. So every time I see a drag, I add these points to my array, and this array content is painted on my screen using the paint component. Of course, I don't call my paint component method myself. The system calls it automatically. And doesn't matter where I move my window, it is minimized, maximized. It is always going to paint it nicely from my internal array. Okay, so that was another example with the mouse drag events. Like the mouse events, there is a interface for key listeners. Okay, so what kind of things we can do with the keys? Key pressed, key released, key typed, etc. Usually we don't look for this kind of stuff because we have our text entry fields and etc. because they handle this kind of stuff. But sometimes I may have to do this. So let's see one example. Let me show you the output demo actually. Okay, so it's going to do this. 3 lines. Key typed. This key is not an action key. Modifier keys press none. Okay, so if I just press the key A, this is what I get. If I press the capital A, okay, that's what I get. If I press the shift key, okay, I can get to. And if I press the L key with the shift, then I can get this. And if I press the L key with the shift, okay, this one. How about F1? If I press F1, okay, this key is an action key. F1 is an action key. L is not an action key, right? And if I can do it with the shift F1, it will work too. Okay, so I can get those kind of information from this example. Again, the main is very simple. Let's look at the class itself, JFrame class. Okay, I am extending JFrame. See, well, this is kind of a trick. Let's look at line number 9. Line number 9. It says, I am a JFrame, but I also implement key listener. So this key demo frame is both a listener and a JFrame. So that means what? This key listener has to this key listener class, this key demo frame class, it has to implement whatever this key listener interface offers. Okay, and it is going to become a listener for itself too. So that's one technique. Interesting. Okay, so the constructor I call the supers constructor. I have this text area. I have this text area of 10 and 15. Okay, text area, we did not use this before. Previously, we used the text entry fields, text fields. It was a single line of text entry field, but now this one has lines, okay, 10 lines and 15 columns. Okay, and we set the text as this, press any key on the keyboard, and the set enabled is false. So this is disabled text area, nobody can type to it. Okay, and disabled color is black, so I make it black so that everybody knows that it is disabled, and I add it. So it is just one component in it. And look at this one. It adds itself as a listener because I am a key listener. Since I am a key listener, I can add myself as a key listener. Since I am a key listener, I have to implement this key pressed, key released, and key type method because these three are defined inside this key listener interface. Okay, let's look at this key pressed. Okay, I make a new format. Okay, string format, key pressed, and I set. Okay, I get the key code, event.key code. It's like, remember for the mouse events, you get the X and Y positions of the mouse events. Now this time we are getting the key code. Okay, I get the key code and I convert it to a string and I make it a line and I set my line 2 and 3. I set my lines 2 and 3 with the event. I will have to see what is line 1. Okay, line 1, line 2. These are my fields. Okay, instance variables, line 1, line 2, and line 3. I set line 1 to this one, then I set lines 2 and 3 with this thing. Okay, so I'm doing the same thing with the key release and key typed. Let's look at set line 2 and 3 with the event. Yeah, it says that is this an action key, then I'm setting it. And are there any modifiers? I am setting it to. And I set the text of my text area with line 1, line 2, and line 3. And at the end, I get these results. So every time something happens, this method is called. At the end, set line 2 and 3. Looking at the event, I can do all that kind of stuff. Okay, so this is how we handle the keyboard events. So we looked at how to handle the keyboard events. We looked at how to handle the mouse events. We looked at how to handle the specific events about J components like the item action item events, action events, status change events, and etc. depending on the component type. So we almost know everything about the events and different types of components. Okay, good. So we did not look at this layout managers very carefully. We said that we are going to use the flow layout most of the time. That's what we did. But flow layout is not the only way of laying out your components. There are a few other ways of doing it. Let's look at them. Okay, this is the simplest layout manager. We use it. Okay, the components are placed left to right in order they are added. Okay, when you add something, it is added to the left, then the right, then the right, and it goes that way. So the adding order to your JFrame is important for the flow layout. That's one thing. Border layout is different. In the border layout, you will say that this component will be in the center, this component will be at the bottom, this component will be at the top or north, etc. So with the border layout, you specify them. With the grid layout, it's like a grid. You would say, okay, you would say, I have a window like that. This will be a 3x4 window. It's a grid, right? So whatever you add will be added to these grids one by one. Okay, so let's see one example of, I already did the flow layout, right? Let me show you the, okay, so this one. So I have 3 buttons, left, center, and right. So whenever I click on this left button, I am going to change the alignment of these buttons to the left. If I press right, it will be aligned to the right. Okay, if I press center, they will be aligned around center. So that's what we are going to do. Again, the main is almost the same. Okay, let's look at this one. Okay, flow layout extends frame, flow layout, super. Okay, layout is my new flow layout, and my container. Okay, what is container? Container is this. Remember our class hierarchy that comes from the object. Container was one of the classes in my hierarchy. I get my container of my current frame. Okay, I set my layout like that. I am going to use this container to do the to change my layout parameters later. And I have this left button, and I add this left button, and I added an action listener for this button using an anonymous inner class. Remember the action listener, action performed. So I am setting the alignment of my layout, which was this one, okay, to the left, and layout container, okay. This is what you need to do to make all the things enabled in terms of alignment. Okay, that's what you do. For the center, I am doing almost the same thing, but this is a copy paste code, not a very good code. Only this part is different, right? Only that part is different. The rest of them is the same, and I'm going to do the same thing for the right again. Only this part is different. Okay, so that's it. So I can play with the parameters of the flow layout. I can align it to the left, right, and center. So that was an example for flow layout. How about border layout? Border layout is going to be something like that. Let me show you the example, okay? So I will add 5 buttons, okay? This button's position will be center. This one will be on the left, and this one will be on the right, and north and bottom, okay? So whenever I click one of them, I will hide that button. If I click some others, I will hide that button, but I will make everything else visible again. Okay, my main is like that, no changes. Let's look at this program. Okay, I have button list, and these are the names for my button list. There are 5 of them, and I am going to use a border layout. Okay, border layout frame. See, it is both extends frame and implements action listener. So that means that I will be my own action listener. Okay, border layout 5 and 5. 5 means that there will be 5 pixel gap between the components. Set layout here in this case is going to be border layout. Okay, it's going to be border layout like that. And my buttons are new buttons, 5 of them. Okay, so this is a button reference list. In this loop from 0 to 5, I will make new buttons and I will add action listener to each of them. So this is the action listener for all the buttons because I am an action listener too. Okay, and I add all these buttons. One of them is the north, south, east, west, and center. Okay, so let's look at this action listener stuff. Action performed. If I get a new action, button action, I scan all of my buttons using this enhanced for loop. And if I found the source to be the same as the button, then I just set the visibility of that button to false. Everything else will be true. Okay, only the button that is pressed will be clicked is invisible. Okay, so as before, I just set the layout container, get content pane. Good, so that's it for the border layout. And for the final layout strategy, I have the grid layout. Let me show you the grid layout. Okay, here I am saying that my grid layout will be, okay, 2 by 3, 2 lines and 3 columns. This one is 3 by 2, 3 lines and 2 columns. Okay, you can have n lines and columns with the grid layout, and you can change the gaps between them too. So this is the grid layout. Let me show you the case. Okay, so again, the same technique: extends frame and implements action listener for the grid layout for the buttons. I have button array. I have the names of the buttons. There is a toggle boolean flag at the beginning. It's true. I have the container and grid layout. I have 2 grid layouts. Okay, one of them will be 2 by 3. The other one will be 3 by 2. Okay, so as you see, grid layout 1 is 2 by 3. These are the gaps between the buttons. This is a 3 by 2. So if somebody clicks on one of the buttons, I am going to toggle between this layout to this layout and vice versa. Okay, set layout is grid layout 1 at the beginning. Okay, and my buttons, 6 of them, and in a for loop I make my new buttons, and for each button I add this action listener because this is my class and I'm doing this button action listeners. And since I am an action listener class, I get the event. If toggle is true, then I set my layout to grid layout 2. If it is false, then I'm going to set it to 1. And I toggle the toggle from false to true, true to false. And I validate my container so that it repeats itself. So that's it about the grid layout. So we have seen 3 types of layout strategies. Okay, good. So layouts are different than components because layouts make a decision about how to arrange your components on the window. Okay, good. So what else? Sometimes adding components one by one to the whole panel is not a desirable thing. Sometimes maybe you want to have more than one panel, and you can do so. And for each panel, maybe you will have different layouts. Okay, that's what we are going to do in this last example. Let me show you This one, okay. Okay, I have this panel, okay. I have two panels. One panel is this. The other panel is this. Okay. This one has flow layout. I don't know what this one has, the upper one. Okay. I don't know what that one is. So I think it is going to be like this. Okay, maybe. No. No. Let me show you this one. No. Okay. Let me show you this one. So again, no difference in the main method. Do I have a... Yeah, well, this one is a JFrame itself. Panel demo extends JFrame. Okay, panel frame, new panel frame. Well, it is almost the same thing. Let me go there. This one has one panel and one buttons. So what I'm saying here is that you have a panel, and inside the panel, okay, so I have these buttons, and I have a new panel here, button panel, and I change this button panel layout to grid layout from 1 comma buttons length, and I keep adding my buttons to my new panel, and I add my panel to my JFrame. So you might have a hierarchy of panels, and each one may have its own flow layout. That's what I'm saying. Okay, so it is possible too. So the possibilities maybe are endless, but again, I am not going to talk. Again, this is not about the course about graphical user interface programming. I just show you how the object-oriented programming techniques could be useful for managing these kind of complicated programming examples. I mean, this we are talking about tens of thousands of lines of code, okay, about the graphical user interface programming. With the help of the object-oriented programming, by writing 30 lines of code, 50 lines of code, you can write, well, most of them are simple, but you can write some complicated programs without knowing the details of what's happening with the GUIs, without paying any attention to the details of GUIs. You just do whatever you want. You concentrate on your task at hand. The rest of them is nicely handled by the library itself. And this is not a limiting approach, actually. I mean, if you like to do detailed programming, if you like to change lots of behavior, then write your own classes and make your classes part of the graphical user interface hierarchy, etc., and it will work that too. So very good examples for object-oriented programming with this GUI library. The same thing happens with the multi-threading library, or the graphics programming library, or the networking library. They are all available, and I made all the slides for the other types of libraries available in our Teams page. And but I'm not going to talk about them. I don't have the time. I guess I am out of time, and I will stop here, and that will be end of the lectures of this semester. I hope you learned something from these lectures of object-oriented programming, both in C++ and Java. Our final will be on January 17th. Okay, it will be a 3 or 3.5 hour exam. You will be responsible from all the subjects, C++ and Java, everything, including the graphical user interfaces. Of course, I am not going to ask you the parameters of the Jpanel constructors. No, nobody remembers those, but you should know about the event-based programming. You should know about the anonymous inner classes. You should know about the layout managers and etc. General stuff, of course. But other than that, you are responsible from all the things that we covered in the class. Also, anything that you learned from your homeworks too, you are responsible from those 2. Okay, are there any questions before we say that's the end of the lectures for the semester? Okay, yeah, your silence is very concerning for me. I hope you are so silent because you are shy to talk. If you are not talking because you did not understand things, well, I hope that doesn't happen. Okay. Good luck with your exam. Study hard. If you have any questions, just send me the question or the TA the questions. We will try to answer them. Your homework, new homework is coming. Homework number 8. It's going to be an optional homework actually. If you like to do it, it will be 100 points extra for you. So you will have 7 compulsory homeworks and 1 optional homework. Okay. I'll see you during the final exam at the campus. Thank you.